All right, welcome to the video for lesson number 11, graphing. So in this lesson, we kind of just reviewed all the things that we talked about regarding graphing our trig functions, especially sine and cosine. Notice we haven't graphed tangent or anything like that yet. We'll do that later. So looking at this first question, it says sketch one cycle of the sine function with an amplitude of 2, a period of pi over 2, midline of y equals 4, and passive at the point 0, 4. So the first thing we want to do anytime we're graphing one of these is to sketch in or draw in the midline. So if we draw in the midline here, so I'm just going to make a nice little dotted line here to show the midline, because again, it's really just a point of reference. Now, since this is a sine curve, we know that the sine curves go up and back down, something that looks like that. So the sine curves start at the midline. That's nice because it's going through that point, so that's already one check mark for us. Since the period is pi over 2, I'm going to go out 4 boxes, make that pi over 2. Since the amplitude's 2, every quarter turn I'm going to change where I am. So after 1 box, I'm going to go up 2 units. After 2 boxes, I'll go back to the midline. 3 boxes, I'll go down 2 units. And then after the full 4 boxes, I'd be back where I started. So my graph would look something like this. The equation of this graph would be y equals 2 sine of something times x plus 4. To find that number that I have to put in there, that frequency, I have to remember that the period, pi over 2, times the frequency is equal to 2 pi. Multiply both sides by 2 over pi, 2 over pi, and we get a frequency of 4. So that becomes 4x. I know I didn't really ask you to do that part yet, but I could on a quiz or test. Number 2 says sketch one cycle of the cosine function. So the cosine function looks something like this. It says that the midline is 1, so the first thing I'm going to do is draw that out. And since the amplitude is 3, I'm going to start 3 units above the midline, which goes through this point. Good job. And since the period is pi over 4, I'll go 4 boxes and make that pi over 4. How the cosine curve works is every quarter turn we change. So from the maximum to the midline. Half term, we're going to be at the minimum. 3 quarters, I'd be back at the midline. And after a full rotation, I'd be back to where I started. Again, I just need to graph 1 cycle, so that's all I need to do. Just like before, if I take the period, pi over 4, multiply it by the frequency, that gives me 2 pi. Multiply both the top and bottom here, so flip that fraction around, and I get a frequency of 8. So my equation would be y equals 3 cosine of 8x plus 1. If you could do number 2, you could do the quiz question tomorrow. It's almost the same exact question. Number 3 says to sketch this over the interval from -8 to +8. Again, that's just telling us what the interval is. So first, when you're given an equation, you have to remember that you need to know what the period is. So the frequency in this case is pi over 2. So I'm going to say the period times pi over 2 equals 2 pi, multiplied by 2 over pi. So the period in this case is going to be 4. So that means every 4 units, I'm going to wind up getting a full cycle of the sine curve. So if I want to go out to 8, I'm going to make this 4, 2, and I'm going to need these little half markers. Same thing if I want to go to -8, I'm going to go -4, and I'm going to need these little half markers to make my curve. So I'm going to have -2, -6, and +6 as well. So since the period is 4, I'm going to see 1 full sine cycle over the course of this, those units. right, so back at it here. So if we are looking at this graph, I see that the midline is 3, so I'm going to draw in the midline at 3. It also tells us that it's going up or down 4. Now, if I want to go up or down 4, that's going to take me off the screen, which is okay, but let's not do that. So instead, let's make it so that these boxes are worth 2. And then 3 would be halfway through one of these. We'll just make my sketch better. So since it's a sine curve, I know I start at the midline. And I'm going to start by going down 4 because of this negative. So if I go down 4, I'd be at -1. Back to the midline. Then I need to go up 4, which I'd be at 7. And then back to the midline. So after 4, I see one full cycle of the sine curve because the period was 4. I then have to duplicate that because it asks me to graph all the way out to 8 and all the way out to -8. So I'll keep duplicating, just following the pattern. That's what our graph should look like. If you graphed it without going up by 2s, if you went up by 1s and went off the screen, it's okay. The last question says, describe the sequence of transformations that map sine onto this new graph, negative cosine of x plus pi plus 1. So the first thing I want to do, let's just graph both of these for a second because we haven't done a ton of graphing here. So let's go to my graphing calculator here for a second. So we have y equals sine of x and negative cosine of x plus pi. And let me just check what was x plus pi plus 1. Remember, when you graph trig functions, you want to be in radians, and you want to use zoom trig. So that blue graph, that's going to be the sine function. And this new red graph is going to be that cosine function. And because I can, I'm just going to take a picture of this. And then we could draw on it, and we'll see what this kind of looks like. So, essentially what this question's asking is, what do you have to do to get from the blue graph back to this graph? So this represents pi over 2, or 90 degrees. This represents pi, 3 pi, and you get the idea going all the way up to 2 pi. But each one of these little dash marks represents 90 degrees, so pi over 2 radians. So for sure, I'm going to have to move to the left 90 degrees. I also know I have to shift up 1 unit. And because it's a sine curve, if I was to take this graph, let me just grab one cycle of this sine curve here. So if I was to graph one cycle of this sine curve, I can shift it up 1, and then I can shift it back 90. That would wind up being right on top of the graph. So I don't really need to do much to make this work, right? So let's just show that again. So here's the sine curve. I could shift it up 1, and then to the left 90. And then the graphs wind up being on top of each other. So what do I have to do here for this to work? So to be able to do all of this, I really jacked this up. Hold on. So let's move all this out of the way. Okay. So describe a sequence of transformations that would map this graph onto the other one. Well, we kind of just said that. So we're going to move, we're going to translate up 1 unit and left pi over 2 units. This is not the only answer. This would just be the most efficient answer without having to do reflections and multiple translations and stuff like that. So if you got something different and you're confused and you want to see if yours is right, just ask me tomorrow in class and we can check it. Hopefully this video helps. Again, remember you do have a quick quiz after this lesson, or not really a quick quiz, just a quiz on graphing, right? So just know how to graph a cosine function like number 2 in the homework and you'll be fine. Hopefully this video helps and I'll see you tomorrow.